Okay, so hi everybody. So we're going to go ahead and work through numbers 5 through 10, no, sorry, 5 through 8 today on the FRQ packet that we have. And this is the data graphs only, okay? So all these are going to basically be the same types of questions, okay? So let's go ahead and get right into it, okay? So we have this graph here. This is let f be continuous function defined on -4 to 3, whose graph consisting of 3 line segments and a semicircle at the origin is given above. Let g be the function given by g of x equal to the integral from 1 to x of f of t dt. This is the graph of f. Right away, you know we're going to use the second fundamental theorem of calculus. Like almost certainly, we're going to be taking the derivative of this, okay? So anyway, find the values of g of 2 and g of -2. Okay, so first let's do g of 2. I'll make this a little bit clearer. Okay, so we have g of 2 is going to be equal to the integral from 1 to 2 of f of t dt. Okay, so all I have to do is use the area under the curve here to go ahead and evaluate what it is. This is a little bit tricky here because they don't actually give you what the coordinates are at 2. So I'm going from 1 to 2, so I just need to figure out what this area is right there. You know it's going to be below the x-axis, so this is going to be a negative value because we're integrating from left to right. And then I just have to find the area of that triangle. Well, this is 1. Now, it is tricky because you have to figure out what the slope of this line is. If you notice the slope goes, or the line goes over 2 and down 1, so the slope is -1/2. So if it goes over 2 and down 1, it's going to go over 1 and down 1/2. So the area of this triangle is 1/2 the base, which is 1, times the height, which is 1. So I have 1/4. So this answer is going to be -1/4. Okay. Furthermore, we have g of -2. Now, right away, you should notice I am integrating backwards, right? I'm going like out of order. It should be from -2 to 1, but I'm going from 1 to 2. So my answer is just going to simply be the negation of whatever I would normally get. So f of t dt. So I'm going from 1 to -2. So I'm going right here. Okay, so I have a triangle and I have a semicircle. Okay, so this triangle has a base of 1 and a height of 3. It's given right here. So 1 times 3 is 3, divided by 2 gives you 3 halves. So this is 3 halves. And then this right here is a semicircle. The formula for the area of a semicircle is pi r squared over 2. So the radius is 1 here. So this is pi over 2. So the area of this is pi over 2. Now, normally, this would be a negative value, not be a positive value. But once again, I'm going backwards, so I have to take the negation of it. Okay, so this right here is going to be positive. So I have pi all over 2. And then up here is going to be negative. So this is -3 all over 2. So this is pi -3 all over 2. Okay, so that's g of -2 and g of 2. Okay, next question. B. For each of g prime is equal to -3 and g double prime of -3, find the value state why it doesn't exist. Okay, so let's go back up here. I'm going to make like my toolbox that I talked about before. So g prime of x by the second fundamental theorem of calculus is simply equal to f of x. And then g double prime of x is equal to f prime of x. Okay, that's my toolbox. Those are the things that I'm going to use. Those are the tools I'm going to use to solve this problem. So here I need to find g prime of 3. Well, by my toolbox, that's just equal to f of 3. Okay, and if I go up to the graph up here, I have f of 3. So I have 1, 2, 3. So I'm at -1. Okay. Then I have to do g double prime of, oh shoot, I did the wrong one. It's supposed to be -3. Okay, so this is -3. This is -3. So this is probably not going to be -1. Let's go back here to -3. So -1, 2, 3. I'm right up here, whatever y value that's going to be. Now, once again, you're going to have to do a little work here. You're going to have to figure out what the slope is of this line. So if you notice, you go from -2 to -4. So you go back 2, and you go from 3 to 1. So you go down 2. So the slope of this line is 1. So if you go back 1, you should go down 1. So it's going to go down to 2. So this is going to be +2. Sorry. Okay, and then g double prime of 3. Well, g double prime of 3 is f prime of 3 of negative. Once again, we're at -3. Okay, so you have g double prime of negative 3 is equal to f prime of negative 3. So if you go up to the graph at negative 3, the slope is 1. So this is just 1. Okay, so you have your answers right there. Okay, next page, C. Find the x-coordinate at each point of the graph G where it has a horizontal tangent line. Okay, so horizontal tangent line of G means you need to find where G prime of x is equal to 0. Well, we know G prime of x is equal to f of x. So all I need to do is figure out where f is equal to, where f of x is equal to 0. Okay, so go back to the graph over here. So this is the graph of f of x, and if you notice f of x is equal to 0 here at negative 1. So you have x is equal to negative 1, and you also know it's equal to 0 at x is equal to 1. Because there's two different places where f of x is equal to 0. So find each x-coordinate at the point which the graph is a horizontal tangent line. Boom, found them. Okay. For each of these points, determine whether G is a relative minimum or relative maximum or neither min or max, and justify your answer. Okay. So go back here. Remember, this right here is the graph of f, which is equal to the graph of G prime. So I know G prime is equal to 0 here and there. And then the derivative goes from a positive to a negative. That means it goes from increasing to decreasing. So right here, there's going to be a relative maximum value. And then here, it goes from negative to negative, so nothing happens here. Okay, no relative mins or no relative maxes. Okay, so going back here, negative 1 has a relative max, and the other one doesn't have anything. So there is a relative max, and we'll go ahead and write all this out. So there is a relative max value at x is equal to negative 1 because g prime of x goes from positive to negative there, meaning the graph of G goes from increasing to decreasing. Okay, nothing happens at x is equal to 1 because G prime of x goes from negative to negative. Okay, tells us nothing. Okay, so D, for x between negative 4 and 3, find all values of x for which the graph of G has a point of inflection. Okay, so point of inflection, so that's the second derivative. So I need to determine where G double prime of x is equal to 0 and then figure out where it flip-flops. Well, G double prime of x is equal to f prime of x. Okay, so we go back to this graph, and this is the graph of f. And so f prime represents the slope of the tangent line here. So where's the slope of the tangent line of this graph equal to 0? There's only one location where it's equal to 0, and that's at x is equal to 0. Now the question is, does it switch concavities there? And the answer is yes, because the first derivative of f, or the second derivative of g, goes from a negative value here to a positive value there. So it goes from concave down to concave up, so it does switch concavities. Okay, so at x equals to 0, g of x has a point of inflection. Okay, this is because g double prime of x goes from negative to positive at x is equal to 0, meaning g of x goes from concave down to concave up. Okay, meaning it has a point of inflection. Okay, and that is it for number 4. Number 5. Sorry, number 6 is off now. Okay, same type of a question. Okay, look here. Right away, you can see we're probably going to take the derivative here. You have the curve. You have to find the area probably underneath the curve, and then so on. Okay, so continuous function f is defined in the interval from -4 to 3. The graph f consists of 2 quarter circles. So here's a quarter circle right here, right there. And then this right here is a quarter circle as well. So I'm going to have to find those areas more than likely. Okay, and one line segment. So there's the other line segment as shown in the figure below. Let g of x be equal to this. So g of -3 is equal to the 2 times -3 plus the integral from 0 to -3. Notice we're going to integrate backwards here. So we have to take the negation of whatever our answer is going to be of f of t dt. Okay, so it's equal to -6. I'm going to go from 0 to -3. So this is -3. Here's a quarter circle. So the formula for the area of a quarter circle is going to be pi r squared, but over 4, because there's going to be a quarter of it. The radius here is 1, 2, 3. So this is going to be 3 squared. So 9 pi all over 4. That's what this area is equal to. I might as well do it right away right here because I'm going to end up doing the same thing here. So I'm going to take pi r squared all over 4. If you notice the radius is just 1, so this right here is pi all over 4. That's what this area is right there. Okay, so I'm going from 0 to 3, 0 to -3. This is up above the x-axis, so this is a positive area, if you will, or positive value. However, we're integrating backwards, so this actually be negative. So this should be minus 9 pi all over 4. Okay, and that would be your answer. Okay, g prime, we have to find g prime. So g prime of x is equal to, so the derivative here, once again, I have the second fundamental theorem of calculus. This is going to be 2 plus f of x. And then I have to figure out what g prime of -3 is equal to. So g prime of -3 is equal to f plus f of -3. Here's the graph of f. So we go to -3, or f of -3 is 0. So this is 2 plus 0, which gives me 2. Okay, and I need this as my answer as well. Okay, B. Determine the x-coordinate of the points at which g has an absolute maximum on the interval from -4 to 3. So if I'm doing absolute maximum, I have to check the endpoints. So I have to figure out what g of -4 is equal to, and I need to figure out what g of 3 is equal to. Okay, so just using the formula that I have up here. So and there's another quicker way to do this. Just by analyzing the graph, I think it's a little bit more confusing, so I'm just going to stick with this. So this is going to be the integral from 0 to -4. Once I'm going integrating backwards, so I have to take the negation of what would normally be my answer of f of t dt. So if I go from 0 to 4, okay, so this right here would normally be positive, and that would be normally be negative, but everything is flip-flopped because I'm integrating backwards. So this is going to be pi over 4 minus 9 pi all over 4. And that's going to give me -8 pi all over 4, which is equal to -2 pi. Sorry, I was way off there, off the screen. Okay. G of 3 then is going to be integral from 0 to 3 of f of t dt. So going back up here, I just have to go from 0 to 3. So 0 to 3, I need to figure out what this area is. If you notice, those are exactly the same triangles. So they cancel each other, regardless of which direction I'm going. So this will be equal to 0. Okay. Now I need to do absolute maximum. So I also need to pay attention to where there's a potentially be a relative maximum value of g. So to find relative maximums, you need to figure out where g prime is equal to 0. And g prime is f of x, so I need to know where f of x is equal to 0. Well, look, I have 1, 2 locations where it's going to be equal to 0. Now, g prime is just the value of f of x, and from -4 to -3, it's below the curve, so the derivative is going to be negative and then goes positive. What that means here is that the graph of G goes from decreasing to increasing, which means that this is a relative minimum value. Okay, over here now, the value is going to go from a positive to a negative. So right here is going to be a relative maximum value. So that means is I need to figure out actually what is going to happen at that point. Now, what is that point? Don't know, do I? Okay. If I had to take a guess, it'd probably be 1.5, right? It's like halfway between there and there. But I should verify this. Okay, so the slope of this line, I'm going down to 1. So 1, 2, 3, 4, 5, 6. I'm going down 6 and over 3. That means the slope of the line is -2. So if for every one I go down, for every 2 I go down, I should go over 1. So if I go down 3, I should go over 1.5. So this is 1.5. So I then need to figure out, okay, well, what is G of 1.5? Well, that's the integral from 0 to 1.5 of f of t dt. And if you find the area here, so you have 1.5, so you have, so that's 3 halves times the height, which is 3, and then divided by 2. So this is going to be equal to 3 times 3 halves all over 2, which is equal to 9/4. So what's going to be the absolute maximum value? You have -2 pi, 0, and 9/4. So your answer is 9/4. Okay. Okay. Let's go ahead and go to C. Okay, so C, find all values on the x on the interval from -4 to 3, which the graph G has a point of inflection. Justify your answer. Okay, or give reason for your answer. So if you go back here, point of inflection of G, so that means G double prime of x is going to be equal to 0, which means f prime of x will be equal to 0. So where at on this graph will the slope of the tangent line be equal to 0? There isn't any places. There aren't any places. Okay. The derivative here is not equal to 0 because it's an endpoint. The derivative here is not equal to 0 because that is a sharp corner. There aren't any places where it's equal to 0. But that still doesn't mean that it can't be a point of inflection. Okay, point of inflection means the derivative or the slope of the tangent line is going to switch, or sorry, the concavity is going to switch, which means it goes from negative to positive, positive to negative, the second derivative. Okay, so the second derivative here, so if you look, is the slope of f. So positive, 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 undefined, negative, 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 negative. So we do have a candidate here at x is equal to 0. So let's take a look at x is equal to 0. That's a place where it switches concavities. Now, would that be a point of inflection? In order for it to be a point of inflection, it has to be a point. So does G of 0 exist? Okay, does it actually exist? So G is just this integral. So you have G of 0 is equal to 2 times 0 plus the integral from 0 to 0 of f of t dt, which is equal to 0. So yeah, G of 0 does exist. It's equal to 0. It switches concavities at that spot. So there is a point of inflection at x is equal to 0 for G of x. Okay, this is because G of x goes from, and what do we do? The slope was positive and went to negative, so it went concave up to concave down. From concave up to concave down at that point. We'll actually write that at x is equal to 0. Okay. D, find the average rate of change of f on the interval from -4 to 3. So there is no point C between -4 and 3, for which C prime of C is equal to the average rate of change. Okay. How do you find average rate of change? The way I always like to do this is I like to go back because like what I find is my students have a hard time knowing because they know it's something like f of b minus f of a over b minus a. You know it's something like that. But the problem is it f of b minus f of a, or is it f prime of b minus f of a, and then so on. So I always like find it that my students have a hard time figuring that out. Okay, so what I usually do is I talk about, well, how do you find the average rate of change? Well, average rate of change is you add up the rate of change and you divide by how long it took you to do that. So what does that mean? We're going to add up the average rate of change. That means that we need to integrate, because that's adding up an infinite amount of different things, the derivative, because the derivative is the rate of change of f, right? So I'm going to integrate from -4 to 3 of f prime of x dx, but then I'm going to divide by the length of the interval. Well, that is 3 minus a -4. Well, how do I do this? I don't have a graph for that. But by the first fundamental theorem of calculus, I know that this is equal to 1 over 7, because 3 plus 4 is 7. And then this right here, by the first fundamental theorem, is equal to f of 3 minus f of -4. Okay? So we plug this in. So I have 1/7 f of 3. Come back here. F of 3, we figured out was -3. Minus f of -4. So let's go back to -4. -4 is -1. So minus a -1. So this is equal to 1/7 times -3 plus 1 is -2. So this is equal to -2/7. Okay, so that is the average rate of change on that interval. Okay, so there is no point C between -4 and 3 for which the derivative of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, what does the mean value theorem state? So there's two conditions that have to happen with the mean value theorem. One, it has to be continuous on the interval, and then two, it has to be differentiable on the interval. Okay? So if I'm looking at f, is f differentiable on the interval from -4 to 3? No, it is not differentiable on the interval from -4 to 3, because you can see at this point it has a sharp corner, which means it's not differentiable. Okay? So explain. This does not contradict the mean value theorem because there is a sharp turn at what was that, x equal to 0. Meaning I did it wrong, and I want to use it. F of x is not differentiable there. Okay, and that is it for 6. On to 7. Okay, so number 7. The figure above shows the graph of f prime, the derivative of the twice differentiable function f on the interval from -3 to 4. There we are. They love -3 to 4. The graph of f prime has horizontal tangents at x equal to -1, x equal to 1, x equal to 3. So right there's a horizontal tangent, horizontal tangent, horizontal tangent. The areas of these regions bounded by the x-axis in the graph of f prime on the intervals from -2 to 1, 1 to 4 are 9, so -2 to 1, So this right here is going to be 9 and 12 respectively. So 1 to 4, this is going to be 12. Okay, find all x coordinates of f which have a relative maximum. Well, that means that f prime of x has to be equal to 0. This is the graph of f prime. So f prime is going to be equal to 0 at x is equal to -2, x is equal to 1, and x is equal to 4. But in order for it to be a relative maximum, f prime of x must go from, what am I doing? From positive to negative there, okay? So take a look, the derivative is gonna go from positive to negative there, so that is a relative max. There's a relative max at x equal to -2. This is gonna go from negative to negative, so that's not 1. And this goes from negative to nothing, so that isn't 1, okay? So there is only a relative max value at x is equal to -2 because f prime of x goes from positive to negative at x is equal to -2. Okay? Okay. B, on what open intervals contained between -3 and 4 is the graph of f both concave up and decreasing? So concave up means the second derivative of x has to be greater than 0, and decreasing means f prime of x has to be less than 0. Well, this is the graph of f prime, right? So if you notice, it's negative from -2 to 0, or sorry, to 1, and 1 to 4. But it doesn't include those because it's at 0 at those points. So this is going to be -2 to 1 in union with 1 to 4. Okay, now the second derivative is the derivative of the first derivative, which means that it is the slope of the tangent line. So where's the slope of the tangent line? Positive. So you go up here. So this is going to be negative, 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 positive, 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 positive. So from -1 to 1. So -1 to 1. Once again, the endpoints aren't included because there's 0 at those points. And then negative, 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 positive, positive, positive. So from 3 to 4, it is also going to be positive. So 3 to 4, the second derivative is greater than 0. So where's the intersection between the two? So -2 to 1 and -1 to 2, the intersection of those is -1 to 1. Okay, and union with, so this is 1 to 4 and this is 3 to 4. So the intersection between those has to be 3 to 4. Okay, so on the intervals, there to there, the graph of f is both concave up and decreasing because f double prime of x is greater than 0 and f prime of x is less than 0 on those intervals. Okay, let's quickly try and get through this. C, find the x-intercept of all points of inflection on the graph of f. Give a reason for your and find the answer. So I need to know where the second derivative is equal to 0. That helps me find it, or where it switches concavity. So where's the second derivative equal to 0 at? It's equal to 0 at -1, 1, and 3. And the second derivative goes from negative to positive, positive to negative, and negative to positive. So they're all points of inflection. So there are points of inflection. At x is equal to -1, x is equal to 1, and x is equal to 3, because f of x switches concavity there. Okay. Okay, D, given that f of 1 is equal to 3, this is just begging me the first fundamental theorem of calculus. Remember, when they give you a point, you should instantly think that. I don't know that what's going to happen, but it should be on my mind. So given that f of 1 is equal to 3, write an expression for f of x that involves an integral, find f of 4 and f of 2. There you are. You're given an equation, a point, you want to find a point. So I know if I integrate f prime of x dx, and I go from, so 1 to 4, so 1 to 4, that should be equal to f of 4 minus f of 1. Okay, so there, I just wrote an expression. Oh, this is actually for the second part. The expression part, I'm actually going to write up here, should be the integral from 1 to x of f of t dt is equal to f of x minus f of 1. Okay, that's the expression they were looking for. Actually, just that expression right there. Okay, so let's go ahead and find this. I have to integrate from 1 to 4. So if I go back and I'm integrating from 1 to 4, I know that that area is going to be negative 12. So I have negative 12 is equal to f of 4, which I'm trying to find, minus f of 1, which is 3. Add it over, so you have negative 9 is equal to f of 4. Okay, by the same principle, I'm going to do the same thing in the other one. So I'm going 1 to negative 2. Take note that I'm actually integrating backwards here. This should be t, t, and then dt. So this is equal to f of negative 2 minus f of 1. Okay, so from 1 to negative 2. So negative 2 to 1, the answer is 9, but I'm integrating backwards. Well, it should normally be negative 9, right? But I'm integrating backwards, so it should be positive 9. So I have 9 is equal to f of negative 2 minus f of 1, which is 3. Add the 3, so 12 is equal to f of negative 2. Okay, I'm going to have to stop there. I'll have to get to 8 later. So that is 5, 6, and 7. Okay, bye, everybody. Thanks.